Bismillahirrahmanirrahim. Assalamu alaikum students. I hope you are all fine and must be enjoying with your life. Students, this is our lecture number 29. Students, this is our lecture number 29 for this subject of operations management, and let's have a review what we discussed in our last class. Students, in our last class we discussed some very important concepts of project management, and especially we discussed the financial analysis of the projects, that how we can use the different financial parameters in order to examine the health of the project, that is whether we should select a particular project or whether we should not carry out a particular project, and if we are having the different projects, then what can be the best project to be carried out by the operations manager. We discussed some important financial parameters like time value of money, and we discussed about the payback period. We discussed about the net present value, benefit cost ratio, and the internal rate of return, and we defined the payback period as the time period in which the initial capital investment is recovered through the generation of the revenues. So of course the projects for which this initial capital investment is recovered quickly, that projects will always be preferred. Then we also discussed the net present value, and we discussed some important examples that how we can calculate the net present value for the different projects, and again we discussed that all those projects are usually preferred whose net present value is greater than 0, and if we have more than one projects, we will always prefer those projects for which the net present value is greater. Similarly, all those projects are preferred for which the BCR value, that is the benefit cost ratio value, is greater than 1. And we also discussed, students, how we can calculate the internal rate of return, and we discussed the interrelationships between NPV, BCR and IRR, that whenever the net present value is 0, the value of BCR will be equal to 1. If net present value is positive, the value of BCR will be greater than 1. If net present value is negative, the value of BCR will be less than 1. And IRR, internal rate of return, is actually that rate of return or interest rate at which the net present value for a project is 0, or when the benefit cost ratio is equal to 1, or we can also say that internal rate of return is that rate of return for which the aggregated discounted benefits are equal to the aggregated discounted cost. And again, students, when we talk about the aggregated discounted benefits, it means the aggregated discounted cash inflows or the revenues. So you must remember that for calculating the net present value, what we do, we calculate the discounted value of all the cash flows, that is the cash inflows and cash outflows, and after calculating the net present value, we can use the particular formula for the internal rate of return. So we also discussed an example, and we actually calculate the internal rate of return for a project. So students, this was what we discussed in our last class. Today, students, in our today's lecture, we will discuss two very important concepts, that is the concept of learning curve and the concept of decision trees. Now we will discuss the definition of learning curve, and we will discuss that what is the application of learning curve with respect to that operations management. What are the different methods which can be used to calculate the learning rate. Again, we can use the three approaches, that is arithmetic approach, logarithmic approach, and learning curve coefficient approach. By using these approaches, we can calculate the learning rate. Then we will discuss the strategic implications of learning curve, and what are the limitations and what are the particular assumptions of this learning curve. Then, students, we will discuss the decision process in operations, and what are the fundamentals of decision making, and again we will discuss the decision tables and decision trees, that how we can figure out the different alternatives in order to have a particular decision. Then again we will discuss the decision making environments, that how we can take the decisions under uncertainty or risk and certainty. Of course, we will also discuss the difference between uncertainty, risk and certainty. Then finally we will discuss that how we can compute the expected monetary value as well as the expected value of perfect information. So these are the important concepts students will discuss in our today's lecture. So learning curve, let me tell you the concept of learning curve, and sometimes it is also referred as experience curve. Now students, this concept is based on the assumption that whenever we do a task and a particular task is being repeated in future, what happens that the time required for the completion of that particular task is gradually reduced. So this is the nature of the human being, that whenever we do a particular task and that particular task is repeated again and again in future, because you are going to have a sort of learning that how to complete that particular task. So in future you may be able to complete that particular task in less time or sometimes with less cost. So that particular concept is usually referred as learning curve. And of course the different human beings and different human resources may have the different learning rates. So this concept of learning curve is based on the premise that people and organizations become better as their tasks are repeated, and the time to produce a unit decreases as more units are produced. So this is the basic assumption behind this concept of learning curve. Students, as I told you, that studies have shown that human performance usually improves when a task is repeated. In general, the performance improves by a fixed % each time the production doubles. So the basic concept of that learning is that whenever the production will be doubled, the time required for the completion of a particular task will be reduced. More specifically, each time the output doubles, the worker hours per unit decrease to the fixed percentage of their previous value. That percentage is called the learning rate. So students, that particular rate at which a particular human resource will learn that how he will be able to reduce the time required to complete a particular task which is actually being repeated in future. So that particular rate is usually referred as learning rate. And again, this learning rate will vary from person to person and organization to organization. Now let's discuss an example so that you can understand that what is learning rate. If an individual requires 10 minutes to accomplish a certain task the first time it is attempted and only 8 minutes the second time. So students, if a person completes a particular task first time in 10 minutes, and again if he repeats that particular task in future, he may complete that particular task in 8 minutes. So you can see he can now complete the task in lesser time. That person is said to have an 80% learning rate. So if we divide that 8 by the initial time for the completion of the task, that is 10, so 8 divided by 10 is equal to 0.8, and it will be equal to 80%. So that person is said to have the learning rate of 80%. If output is doubled again from the 2 to 4 units, we would expect the fourth item to be produced in 6.4 minutes. So again students, if the output is being doubled, then what we can do, we can multiply the recent time required for the completion of that particular job by its learning rate, so we can get the time for the completion of fourth unit of that particular product. So this is student the concept of learning rate, that whenever the different tasks are going to be repeated in the organizational settings, their time required to complete that particular task is generally reduced. And this concept can be represented by this curve you can see on this graph. So on x-axis the number of repetitions are there, and in the y-axis you can always take the time or you can always take the cost. So you can see that in this curve what it conveys, that whenever the different tasks are being increased, the time required or the cost required to complete that particular task is gradually reduced, and you can see after a particular point it will become steady and it may become parallel to the x-axis. So it means that after the certain repetition of the task, that improvement will not be like that, and the time required for the job will be constant further. So it means the time required for the completion of the particular task will be reduced by the increasing number of repetitions, but after a particular time period this will become constant and it may not be further improved. So this is the concept of learning curve. Students, there are different formulas we can use for calculating the learning rate. We can always use this formula, that is time required for the nth unit is equal to t multiplied by capital L to the raised power n, where t is equal to the unit cost or unit time of the first unit, that is the time required for the completion of the first unit of the product. L is equal to the learning curve rate, and small n is equal to the number of times t is doubled. So initially when this formula was given by the different theorists, so it was assumed that every time the production doubles, the time required for completion of the task will be reduced. First unit takes 10 labor hours, 70% learning curve is present. Then the fourth unit will require doubling twice, that is 1 to 4. Let's discuss an example, that is the first unit takes 10 labor hours, and suppose that the learning rate is 70%. Then the fourth unit will require doubling twice, that is 1 to 2 and then to 4. And if we put all of these values in this particular formula, you can see that as given in this particular information, your capital L, that is the learning rate, is 70%, your small n is 2. Now why it is 2 in this particular formula? Because you have doubled the production, so that's why n is equal to 2 in this particular case. And again the time required for the first unit is 10 labor hours. So if we put all of these values in this particular formula, we can get the hours required for the unit 4, that will be equal to 4.9 hours. So these are some of the examples, students, given in your textbook, that how the different organizations are being able to calculate their learning curve rates. You can see that in this model of T4 production, the improving parameter was price. Now again, students, the improving parameter in most of the cases when we discuss this learning rate or experience curve are either the cost, that is price, or the time required for the completion of the different jobs. So in this particular example, the improving parameter is again related to the cost or price, and the cumulative parameters are the units produced, that the production and the cumulative parameter is again the production or the units produced. And in that particular example, when they get the data, they find out the learning rate equal to 86%. Similarly, the other organizations also have their learning rates, and as I told you that the learning rates differ from the organization to organization as well as from the person to person. Let's discuss some of the uses of learning curves. You can see there are some internal usage, there can be the external usage, as well as there can be the strategic implementation of this learning concept. Whenever we want to have the labor forecast, we can again take into account this learning curve concept, because students, as I told you, that whenever we are going to have a forecast that what time may be required for completing a particular task, and especially when that task is being repeated again and again, if we don't take into account the learning curve concept for calculating the total time, then what will happen? You may have the overestimation with respect to that particular forecast. But if you take into account the learning curve concept, then you may rightly estimate regarding your price, as well as regarding the total time required for the completion of a particular job. So in order to avoid the overestimation or underestimation, it is always important to take into account this learning rate concept. So again, this concept may be helpful in scheduling and establishing the costs and budgets. And again, we can always avoid the overestimation and underestimation. Similarly, this concept may be used for the supply chain negotiations. When we are able to find the learning rate, we can always negotiate with our clients as well as with our laborers. Then evaluation of the company and industry performance can also be done by this concept of learning curve, that what is the learning rate of our organization with respect to the learning rate of some other organization. So again, this concept is so helpful in estimating the cost and especially the time required for the completion of the different jobs. Students, there are three different approaches we can use for calculating the learning rate. The simplest approach is this one. Now what we do, now these are the nth unit produced. If we produce 1 unit, the time required for this production will be 100 minutes or 100 hours in this case. The time required for the second unit is 80 hours. Now it means that what will be your learning rate? Your learning rate will be 80 divided by 100, that is 0.8. Now for calculating the fourth unit time, what we can do, we can multiply this learning rate 0.8 by the time required for producing the second unit. So 0.8 multiplied 80 is equal to 64. It means there will be 64 hours required for producing the fourth unit. Similarly, 51.2 hours will be required for completing the 8th unit. So by using that particular formula, we can find out the time required for the completion of a job each time when the production is being doubled. But of course, if you see this particular method, we cannot find out the time required for producing the third unit. So this is the limitation, or this is the assumption of this particular method, that is arithmetic approach. This is another formula for that learning rate, that is Tn is equal to T1 capital N raised to the power small b, where Tn is equal to time for the nth unit. Now students, again, by using this particular formula, we can calculate the time for any unit. Previously, we can only calculate the time required for producing a particular unit each time when the production is doubled. But by using this formula, you can always calculate the time for the first unit, second unit, third, fourth and fifth, or any other unit. So T1 is again the hours to produce the first unit. Small b is equal to the log of the learning rate. Now again, we'll have to divide the log of learning rate divided by log of 2, and this small b is usually called as the slope of the learning curve. So in order to calculate the b, what we will do, we will just divide the log of learning rate by log of 2. So we will have to calculate the value of this b. Now this is the example, students. If learning rate is equal to 70%, and if we put this 70% or 0.7 in this formula, that is b is equal to log of the learning rate divided by log of 2. So b in this particular case will be equal to log of 0.7 divided by log of 2, so it will become minus 0.515. Similarly, if the learning rate is 75%, the value of B will be minus 0.415. In this way we can calculate the value of B. Now again, how we can use this logarithmic formula for the calculation of the learning rate. Now suppose the learning rate is equal to 80% and the first unit took 100 hours. Now if we again put all of these values in this particular formula, Tn is equal to T1 capital N raised to the power B. Now suppose we are interested to calculate the time for the completion of third unit. So in this case N will be equal to 3 is equal to 100, that is T1 multiplied by 3. In this case N is equal to 3 because we want to calculate the time for the completion of third unit. 3 to the power B. Now again, what is B? B will be equal to log of 0.8 divided by log of 2. It will be equal to minus 0.322. Now by calculating this particular value, you can get the third unit time, that will be equal to 70.2 labor hours. So students, in this way, by using this logarithmic approach, we can calculate the learning rate as well as the time for the completion of any of the unit. Another approach we can use for calculating the time required for the production of different units is this coefficient approach. Now the formula for this coefficient approach is Tn is equal to T1 multiplied by C, where C is the learning curve coefficient found in the table. There is a separate table for this coefficient. You may also find this table in your textbook, especially if you see the relevant chapter or relevant module in your textbook written by Hazer. You can always find this table in this particular chapter. Again, Tn is equal to the number of labor hours required to produce the nth unit, and T1 is the number of labor hours required to produce the first unit. Now students, this is the table I was talking about. This table will help you to identify the value of this coefficient. Now you can see these are the different unit of products to be produced, and this is the unit time and this is the total time for the learning rate of 70%. Again, the unit time and total time for these different units and learning rate, that is 85%, is given in this particular table. Now let's discuss a simple example that how we can use this coefficient method to calculate the learning rate. Now students, suppose the first product or the first boat required 125,000 hours. Labor cost is equal to $40 per hour. Learning factor is equal to 85%. So students, our learning rate is 85% in this case. Now if you use this formula, that is coefficient formula, that is Tn is equal to T1 into C, you can see that our T1 is 125,000 hours. So this is T1 multiplied by C. Now if you are interested to calculate the time required for the fourth boat, now what we will do, we will refer to this table, and now this is the table. You can see, you'll have to see the value for the fourth year. Now students, again, in order to identify the value of the coefficient, you'll have to refer to this table. This is the coefficient table. Now again students, we are interested to find out the time required for the fourth unit. So this is 4. You will see the relevant value within the required 85% learning rate. Your learning rate is 85%, so we will refer to these values, and again you will compare this fourth unit at this particular point, and you can see that this is the coefficient, that is 0.723. So we will use this 0.723 here in this formula, and again we can have the time for the fourth boat, that is 90,375 hours for the fourth boat are being taken. Now if we are interested to calculate the cost for producing this fourth boat, now you have already been given the labor cost, that is $40 per hour, as you are going to spend 90,375 hours for the fourth boat. Now the cost for the production of fourth boat will be equal to this 90,375 multiplied by $40 per hour, that is the labor cost per hour. So the total cost for the production of fourth boat will be equal to 36,15,000 dollars. So in this way, students, we can always calculate the estimated cost for the production of a particular unit. Now students, we just discussed the time required for the fourth unit, but not all of the 4 units. Suppose we are interested to calculate the time required for the production of all the 4 units, that is time required for the first unit plus time required for the second unit plus time required for the third and fourth unit. Now in that particular case, what we will do, the value of T1 will remain same, that is 125,000 hours, but the coefficient will change. Now you will refer to this particular value because now we are interested in total time, not the unit time. Previously we were just interested to calculate the time required for the fourth unit only, but if you are interested to calculate the time required for producing all of the 4 units, so we will refer then to this value, that is under the total time heading, and against the fourth units you can find out that this value is 3.345. so the coefficient in this particular case will be 3.345. so it means now 4,18,125 hours will be required for producing all of the 4 boats. So in this way we can calculate the time required for producing a particular unit, or the time required for the production of all the different units up to a particular extent. Now students, suppose we want to calculate the time required for producing the first unit, when we already know the time required for third boat, that is 100,000 hours. Your learning factor is again 85%. Now what you will do, because in this particular case you want to calculate this T1, and the value formula for the T1 will be equal to Tn divided by C. Now this is Tn, that is the time required for the third boat, divided by the relevant coefficient. Again the relevant coefficient in this particular case will be against this 3, that is 0.773. so in this way you can have the new estimate for producing the first unit, that is 129,366 hours. So students, we have discussed some of the examples that how we can use the different approaches like arithmetic approach, logarithmic approach, and the coefficient approach in order to calculate the learning rate as well as the time required for the production of a certain units. And we also discussed that how this method will be helpful for the operation managers for the forecasting purpose and for the estimated cost calculations. As I told you that learning curves differ from company to company as well as industry to industry as well as from individual to individual, so the estimates should be developed for each organization, and it is always good to compare the estimations for your own organization, and you can always compare this estimation with the industry estimates. Learning curves are often based on time estimates which must be accurate and should be re-evaluated when appropriate. So it is very important that how you will estimate the time required for the first unit and the second unit or the other relevant unit, so that the right learning rate should be computed. Any change in personnel or design or procedure can be expected to alter the learning rate. So learning rate or the learning curve actually depends on so many factors, and you will also have to take into account all of these factors for analyzing or for examining the learning curve. The culture of the workplace, resource availability, and changes in the process may also alter the learning curve. So students, these are so many factors which should always be considered when you are going to compute the learning rate for your organization or for your workforce. So students, this was all about the learning curve, and we discussed that how we can use this particular concept in operations management perspective. The next topic we will discuss today is about the decision making tools. Now let's discuss the decision process in the operations. There are 6 steps involved generally for the decision making in the operation settings. That is, first of all, we'll have to clarify and define the problems and the factors that influence it. And sometimes as students, we say that if the problem is rightly identified, the half of the problem is solved. So important is the identification of the problem, and we'll also have to identify that what is the root cause of the problem, that is, what are the factors which are actually causing this particular problem. So this is the very first step in any decision process. Then we'll have to develop the specific and measurable objectives, that is, what are our predetermined objectives to be achieved after that particular decision. And again, you will have to quantify these objectives. It is always important to quantify and make these objectives measurable. Then you can always develop a model, and then you'll have to evaluate the different alternatives, and then you may select the best alternative among the different alternatives available. Finally, you will have to implement that best alternative and set a timetable for its completion. So these are the different steps, students, which you should take for any of the decision. Students, there are 2 important terms we used in the decision making process. One is the alternative. Alternative is actually a course of action or strategy that may be chosen by the decision maker. Now, in order to analyze a particular situation, you may have the different alternatives, so that you will have to select the best alternative among these alternatives. The second important term is the state of nature, that is an occurrence or a situation over which the decision maker has little or no control. Then students will have to discuss the state of nature of the different alternatives, which may be the probability of the occurrence of the different alternatives. So the decision maker will have to analyze this state of nature, that what are the chances of the occurrence of the different situations in future. Different symbols may be used, especially when we are using the technique of the decision tree. We can use this square symbol for the decision node from which one of the several alternatives may be selected. Then again, this circle can be used as a state of nature node, out of which one state of nature will occur. So we will discuss that how we can use these symbols when we are going to formulate the different alternatives, and finally how we can select the best alternative as our decision. Now students, this is the example of decision tree. As I told you that the decision node is actually represented by this square. So this is the square, and at this particular point you have 3 options, that is construct large plant, second option is construct small plant, third option is nothing. Now actually the decision maker have 3 choices before him, that is either he can construct a large plant, he has also the choice of constructing a small plant, or he may not construct the large plant as well as the small plant, and he will do nothing actually. So these are the different choices before the decision maker. And again students, this option of constructing large plant have the different states of nature, and you can see either if you construct the large plant, what can happen, there may be the favorable market situation, and there can also be the unfavorable market situation. Similarly, if you construct the small plant, there may be the favorable market situation, and there may also be the unfavorable market situation. So this is just the example that how we can formulate and show the different options and the sub options in the form of this tree, and this diagram is actually referred as a decision tree. Now students, this is the example of decision table, and you can see there are the different alternatives again before the decision maker. Again, the alternatives are construct the large plant or construct the small plant, or he may do nothing. Now what happens that each of these alternatives may have the different states of nature, and there are two states of nature in this particular situation, that is the market may be favorable or the market may not be favorable. So when the market is favorable and the large plant is being constructed, now what will happen, there may be the chances of $200,000, and if the market is unfavorable, and if the market is unfavorable and the large plant is being constructed, there may be the chances of loss, that is 180,000 loss chances may be there. Similarly students, if small plant is constructed, then under the favorable market condition there may be the profit of $100,000, and under the unfavorable market condition there may be the loss of $20,000. And again, if you do nothing, then nothing will affect under the favorable or the unfavorable conditions. So in this way we can analyze the different situations in the form of a table, and this table is generally referred as a decision table. Now students, there are the different environments under which the decision maker can make the decisions. There are three very important things, that is the uncertainty and the risk or the certainty. Certainty means when you are sure about anything and what will happen in the future, so that particular situation is termed as certainty. But as a decision maker, we are mostly concerned with the uncertainty and risk, and basically there is no difference between uncertainty and risk, but technically there is a difference between this risk and uncertainty. We can calculate the risk because of the availability of the certain historical data, and if we have some historical data, of course we can calculate the risk of the occurrence of the different events in future. But if we do not have any particular data or particular historical data about the occurrence of the particular alternatives in future, then that situation may be referred as uncertainty. So the decision maker will have to make the certain decisions either in the uncertain environment or the certain environment or in that risk environment. Now students, what technique can be used for decision making under the uncertain environment, that is the Maxime X. Now what is Maxime X? You'll have to find out the alternative that maximizes the maximum outcome for every alternative. Now what we do, that we'll have to find out the maximum outcome of the different alternatives. Then among all of these maximum alternatives, again you'll have to select the maximum choice. So this is what is meant by Maxime X. Again, this method can be used under the environment of uncertainty. Now students, in this particular method we pick the outcome with the maximum number, that is the highest possible gain, and this is viewed as an optimistic approach. So whenever we use this Maxime X approach under uncertainty, it is generally termed as optimistic approach. The other method we can use under uncertainty, that is Maximin. Maximin means find the alternative that maximizes the minimum outcome for every alternative. Now students, what we do in this particular method, we will find out the minimum outcome of all the alternatives, and then we will select the maximum choice among all of these minimum outcomes. In this particular case, again we'll have to pick the outcomes with the minimum number, and this situation or this method will help us to have the least possible loss actually, and this is viewed as a pessimistic approach. Another approach we can use for the decision making under uncertainty, that is the equally likely. In this particular method, what we do, we find the alternative with the highest average outcome, pick the outcome with the maximum number, and in this particular method we assume each state of the nature is equally likely to occur. That is, we have the perception that the probability of the occurrence of the different states of nature are equal. Now students, let's discuss all of these three particular methods of decision making under uncertainty. Now suppose we have again this sort of situation that we have the three alternatives, that is constructing large plant, constructing small plant, or do nothing. Now again, if there is a favorable market, there may be the profit of $200,000. If unfavorable market, there may be the loss of $180,000 in case you construct the large plant. In case you construct the small plant and the market condition is favorable, there will be $100,000 profit, and there may be the loss of $20,000 if the market is unfavorable. And again, nothing will happen under the favorable and unfavorable market condition if you are doing nothing. So this is the information we have in this particular situation. Now suppose students, we want to use that method of Maxime X. Now again, what we will do in the Maxime X method, we will have to find out the best option out of the different alternatives. You can see in this alternative of constructing large plant, one option is the $200,000 profit, the other option is $180,000 loss. So we will select the maximum or the best alternative, that is $200,000. Then again, from the second alternative, the two options are either getting the profit of $100,000 or the loss of $20,000. Now what is best? That is maximum, that is $100,000. So that is the option in case of second alternative. Again, in third alternative, that is doing nothing, 0, 0, and again we'll have the 0 in this particular case. Now we have three different options, that is 200,000, 100,000, and 0, and out of these three options, what is maximum? That is again $200,000. So this will be selected as our decision, that is, we will have to construct the large plant, and this is the Maxime X choice actually. Again, what we did, we find out the best options among the different alternatives, and out of all of these best options, we again find out the maximum best option, and this is the method of Maxime X. Now let's discuss the method of Maxime. Now what's in Maxime? We will find out in the each alternative that what is the least preferable option. Now you can see in first alternative, that is constructing large plant, there are two options, $200,000 or $180,000 loss. So what we will select? We will select the minimum value. When we use this method of Maxime, the minimum value is $180,000 loss. In second alternative, again, out of $100,000 or $20,000 loss, the minimum value is $20,000 loss. So again, we will select this $20,000 loss. Third option, again, there will be 0. Now students, again we have three options, that is $180,000 loss, $20,000 loss, and $0 loss. So now out of these three options, we will select the maximum option, that is $0. So it means if we use that Maxime technique of decision making, we will do nothing in that particular case. Again students, what happens in equally likely method? Again, we will find out the average of the different options. We have two options, that is $200,000 and $180,000 loss. Now what we will do, we will add these two options and divide it by 2. So we will get the average of $10,000, and that will be in positive. Again, for second alternative, we will take the average of $100,000 minus $20,000, and again its average will be $40,000. Third option or third alternative average is 0, and again out of these three averages, we will find out the maximum average, that is $40,000, and the relevant option is we will have to construct small plant. So students, in this way we discussed that by using this Maxime X, Maximin or equally likely option, how we can take the certain decisions under the uncertain environment. Now another most important environment which the operations managers usually face is the risk. And again, I told you that this is a particular situation in which we can have the idea or we can have the historical data through which we can find out the percentage of the occurrence of the particular alternatives in future. Each possible state of nature has an assumed probability. So in this particular case, we can calculate the occurrence of the chances of the different events, and the states of nature are mutually exclusive. It means that out of the different states of nature, only one of the state of nature will have to be opted. Then some of the probabilities must be less than 1, and by using this particular probability method, what we'll have to do, we can determine the expected monetary value, that is EMV, for each of the alternative, and then we will find out the best alternative, and the best alternative is that alternative for which the expected monetary value is the highest. So students, this is the formula for calculating this expected monetary value, that is equal to payoff of the first state of nature multiply relevant probability plus payoff of second state of nature multiply by the probability of the second state of nature, and so on. I will let you solve a particular question so you can have the idea that how we can use this particular formula for calculating the EMV. Now students, again let's discuss this particular example again. There are 3 alternatives, and you know that if favorable market condition is there, what happens, and if unfavorable market condition is there, what will happen. Now suppose now we are given the probabilities that there are 50% chances that there will be the favorable market condition in future, but also there are the 50% chances that the market condition may be unfavorable. So in that particular case, what we can do, we can calculate the expected monetary value for the different cases. Now the expected monetary value for first choice, that is A1, will be equal to, as I told you, the formula, that is the payoff of the first state of nature multiplied by the relevant probability. Now you can see that in first case you can have the chances of $200,000 profit. So this $200,000 profit is multiplied by the relevant probability, that is 0.5, that are the 50% chances of favorable market condition actually, plus the second option, that is $180,000 multiplied by 0.5, so it will become $10,000. So it means the expected monetary value for this alternative A1 is equal to $10,000. Similarly, if we multiply this first option for the second alternative by 0.5 plus second option of this second alternative multiplied by 0.5, this will be equal to $40,000. Again, the EMV for the third project will be equal to 0. So in this particular case, again students, the best alternative will be second alternative, which will give you the $40,000 as the expected monetary value. So this is the best option in this particular case. So you see that how we can use this technique of probabilities and EMV to find out the best alternative among the different other alternatives available. Now students, again there is another environment in which we can take a particular decision, that is the certain environment, when we are 100% sure that something will happen, and in this particular case we will determine the expected value of perfect information, and it is generally termed as EVPI, and the formula used for EVPI is equal to expected value with perfect information minus maximum EMV. So students, expected value with perfect information is equal to the best outcome or consequence for the first state of nature into the relevant probability plus best outcome for second state of nature into the relevant probability plus so on. So again, in this particular case, if we take into account the similar example, that is the best outcome for the state of nature, favorable market is build a large facility with a payoff of $200,000. The best outcome for unfavorable is do nothing with a payoff $0. So students, in this particular example, how we can calculate that EVPI, we'll have to find out the best outcome for the state of nature, that is the favorable outcome is build a large facility with a payoff of $200,000. So the relevant probability is also 50%. So what we will do, we will multiply this $200,000 multiply by this 0.5 plus what is the best outcome for the most unfavorable, and in this particular case that will be doing nothing. That is, in this particular case the payoff will be equal to $0, and we will multiply again by 0 multiplied by 0.5, and we will get $100,000 as the expected value with perfect information. The maximum EMV is $40,000, which is the expected outcome without perfect information. Therefore the EVPI is equal to EVWPI minus maximum EMV. This will be equal to $100,000 minus $40,000, that is $60,000. The most the company should pay for the perfect information is $60,000. So in this way, students, by using this particular information, we can calculate the EVPI, that is the expected value with perfect information. Now students, again let's discuss about the decision trees. The different information given in the form of the different decision tables can always be displayed in the form of the decision trees. A decision tree is a graphical display of the decision process that indicates decision alternatives, states of the nature and their respective probabilities, and payoffs for each combination of decision alternative and state of nature. And this is the always appropriate option for showing the sequential decisions. Now students, let's discuss this particular example, and let's discuss that and how we can draw the particular decision tree. Now let's read out this particular problem. That is, Try Products is trying to decide whether to make or buy an accessory item for one of their products. It is projected that this item will sell for $10 each. Now these are important information to be noted down, students. That is, $10 is the selling price of the product. If the item is outsourced, there is virtually no cost other than the $6 per unit that they would pay their supplier. So it means if the item is outsourced, they will bear the cost of just $6. Internally they have two choices, that is, process A requires an investment of $120,000 for design and equipment but results in a $4 per unit cost. So students, if they opt for the process A, $120,000 they will have to pay as an investment, and the per unit cost in process A will be $4 per unit. Process B requires only $100,000 investment, but its per unit cost is $5. Regardless of whether the item is subcontracted or produced internally, there is a 50% chance that they will sell 50,000 units and a 50% chance that they will sell 100,000 units. Draw the decision tree appropriate to the alternatives and outcomes stated. Using the decision trees and EMV, what is their best choice? Now students, let's discuss now that how we can draw that decision tree. Now students, you can see that there are three options in this particular case. Either you can opt for process A, or you can opt for the process B. There is another choice or alternative, that is you outsource. That is, you outsource your product. So students, these are the different initial alternatives you have in this particular situation. Now again, in each alternative there are two particular situations, that there may be the high demand for a product, high demand, and the percentage for this high demand is 50%. Similarly, you may have the low demand for a product, and the percentage for this low demand is again 0.5. The same is the case with this process B, that is you may have the high demand and the relevant probability is 0.5. You may have that low demand and the relevant probability is again 0.5. Now students, again, if you outsource your product, again there are the two choices, high demand or low demand, and again the relevant probabilities are 0.5 and 0.5. Now if you opt for the process A, it is given that in that particular market situation, now students, this is $100,000, and you know that selling price for a product is 10 in this particular case, and the cost in this process A for a single unit is 4. So the total profit for a single product will be equal to 10 minus 4, that is selling price minus cost, and if we multiply this value by $100,000, we can get the total profit in this particular case, and the total investment in this particular case is again 120,000. So this sum will become equal to $480,000. Now again students, if there is low demand, then what will happen? You may be able to sell the 50,000 products. And again 10 minus 4, this will become the profit of $50,000 minus the investment in this particular case is again $120,000. Now this value again will become 180,000. Now in process B, what happens? Again, if demand is high, you will be able to sell $100,000. You will be able to sell 100,000 products. Again, in this particular case, the selling price is same, that is 10, but the cost, per unit cost of the product is $5. So this will give you the profit for $100,000 minus its investment. In this case is 100,000, and this will be equal to 400,000. Now in process B, students, if the market condition is unfavorable, then what happens? You will be able to sell 50,000 products. 10 minus 5, it will give you the total profit minus again the investment, that is 100,000. This will be equal to $150,000. And again students, for third option, that is outsourcing, if the high demand condition is there or the favorable market condition is there, you will be able to sell again $100,000. You will be able to sell 100,000 products, and in this particular case selling price is same 10, and there is only a single cost available, that is per unit cost for the product, that is 6. So this will give you the total profit as 400,000. If there is low demand in the market, again the products sold may be 50,000 multiplied by again 10 minus 6, it will be equal to $200,000. So students, this is the decision tree in which we have the different options, and we have calculated the total profits under the different options for the different alternatives. Now in the next stage we'll have to find out or calculate the expected monetary value for the different alternatives, that is process A, process B and outsource. Now let's calculate the EMV for process A. This will be equal to 0.5, that is the probability of favorable market condition, multiplied by 480,000 plus 0.5, that is the 50% chances probability for the unfavorable market condition, and the relevant profit in this particular case will be 180,000. So its total will be equal to 330,000. Similarly students, if we calculate the EMV for option B, it will be equal to, again the probability 0.5 multiplied by 400,000 plus 0.5 multiplied by 150,000 and this sum will be equal to 275,000. In the same way students, we can calculate the EMV for the option C. EMV for alternative C, this will be equal to 0.5 multiplied by 40,000 plus 0.5 and multiply by 200,000. This will be equal to 300,000. Now students, again you can see that the expected mean value for the process A, that is for the first alternative, is greatest, that is equal to 330,000. So this will be your best alternative. In this way we can have these decision trees, and this decision tree will actually help us to find out the best alternative. Let's discuss another example. So students, again in this particular example the similar sort of information is given. There are the different market conditions, and for which the different options or probabilities are given, and accordingly you will have to use the different alternatives in order to draw the decision tree, so that again we can have the different EMVs for the different options, and accordingly we can calculate the best option out of these available options. So this is the decision tree for this particular situation, and again you can see in this particular example there are three choices, and among these three alternatives there are further the choices under the different market conditions. That is, if the market is receptive, what will happen, and if the market is neutral, what will happen, and the relevant probabilities are always given. So by using the similar procedure we can calculate the expected monetary value for the different alternatives, and again at the end we can find out the best alternative. In this way students, we can use that decision tree technique to find out the best alternatives among the different alternatives available. And this is the end of our today's lecture, and hope you understand all of these concepts, and see you next time. Thank you. Khuda Hafiz.